Okay, hi and welcome to the example video on the notes 8.3, which is exponent properties of multiplication, specifically like bases. So we did a couple in the notes video where we talked about it, but now we're going to go ahead and break into a couple new examples. In this set of examples, we're going to complicate the situation a little bit by including the idea of a variable. So you can see here we've got a couple of variables that we're going to have to do. Variables can be considered like bases as well. So if we look at example 3 here, we've got the like base of x squared being multiplied by x to the fourth. Again, all the same base. So if you recall our notes video, what we're going to do is we're going to take the x's, combine them under one base, and then we're going to take all of the exponents and add them together. But you may question yourself, since that x there in the middle doesn't have a base, it means that it has a base of 1. So we're going to take 2 plus 1 plus 4. And that result's going to be x to the 7th, it looks like. Okay? Nice, neat example. Well, let's look at example 4. In example 4, it throws in the new idea of coefficients. So now we've got a variable with a coefficient. Well, how do we deal with these? What I like to do until I get the hang of it is I like to show how these are all broken apart and then rearrange using a couple properties that maybe we don't realize we're using, one being the commutative property of multiplication. And then we'll treat coefficients like they're not a base, like it actually is a coefficient, and we're going to go ahead and multiply those. So let's take a look at this one. I'm going to take 2 and I'm going to separate it from the n by putting the multiplication there. It's implied here, I just want to see it. Sometimes it makes it a little easier for me. Now I'm going to go ahead and put n to the 5th times the 3 times n to the negative 2. Now what I'm trying to do here is change one rule at a time. And now the secret is there's more than one way to do this. There's never a right way or a wrong way. You just choose to do one at a time, and chances are you won't make any mistakes. So looking at this that I've go ahead and separated, I'm going to employ the commutative property. What that says is since all these bases are being multiplied together, I can rearrange them in any order that I want. Well, the order that I'd like to have is to take 2 and multiply it by 3. I'm going to put them next to each other. And then I'm going to go ahead and put the n's next to each other as well, in no particular order. Okay. Now that I've got them rearranged, I've got my coefficients by my coefficients and my n's by my n's, then I'm going to go ahead and start combining like terms. So 2 times 3, well, that's pretty simple. We're going to change that to 6, which if you look over here by our basic rule, it says coefficients multiply, and that's what we did. We're going to employ the rule of our n's being multiplied, and we're going to add these exponents. So that means I'm going to get one like base, and I'm going to go ahead and add the exponents, so 5 minus 2. And again, you may have been worried about this negative 2, meaning that you have to move it, but let's let that happen. You'll notice that it'll go away. So I'm going to up with 6 times n to the 5 minus 2, which is 3, or 6n cubed. Okay, and then that one's done, no negative to move, and we've completed it. So what we find then is that coefficients multiply, exponents add. And again, you may have to employ the commutative property to rearrange them to get them next to each other. All right, well, what happens if we have different bases? So let's look at example 5. This one you'll notice that we have two like bases of c, and we have one unlike base of d. How do we deal with that? Well, we can employ the commutative property again here, meaning that I'm going to rearrange my c's together using, again, under all multiplication. Notice no addition here. And I can put d at the back. What that allows me to do is have my c's next to each other so that I can combine them under my rule. Like bases being multiplied, I add exponents. And then I can go ahead and multiply that d to the negative 3 on. Now I can deal with that now, but I'm going to go ahead and clean up the c, and then I'm going to address the d, because I noticed that there's a negative there on the d for its exponent. So c to the 4 plus 2 is going to be c to the 6th. Now I'm going to go ahead and address the fact that this has a negative. And if you remember, any base with a negative exponent means move its position and lose the negative. So in this case, let me find my pen. In this case, what's going to happen is this d is going to go to the denominator. 1's going to hold its numerator place, and it's going to become positive. So I end up with times 1 over d cubed. Notice the 3 is not negative anymore, and the d has now moved its position. So if I put those together, and if you need to, put c's to the 6th over 1, multiply numerators, multiply denominators, we're going to end up with c to the 6th over d cubed. And that is simplified as far as we can take it. Because these are unlike bases, there's no more to go. All right, let's see one with lots of different coefficients and variables involved. So here's 6. Again, we're going to employ the same rules. We're going to break it apart. We're going to use the commutative property to move them together, and then we're going to slowly combine them step by step. Again, realizing there's more than one way to do it. So first step, we're going to take and break it apart. So 5 times x to the first, so I can see its exponent, times 2 times y to the fourth times 3 times x to the eighth. Now I'm going to move everything that goes together. So I'm going to put my coefficients in front. So I'm going to take 5 times 2 times 3. And now I'm going to put my like bases together. So I've got x's. I've got an x to the first and an x to the eighth. I'm going to put them next to each other. X to the first times x to the eighth. And then I'm going to multiply that unlike base right on the end. So now I've got everything arranged together. I've accounted for all my parts. I'm going to go ahead and multiply these together. 5 times 2 is 10. 10 times 3 is 30. So my coefficients make 30. My two x's here are going to become one base. That's x to the 1 plus 8. And my y is just going to be y to the fourth. So really the last thing we have to do is clean up this x to the 1 plus 8 and we're done. So this will be 30 x to the ninth y to the fourth. Okay, so in these videos you've seen the notes and the examples of how to deal with combining like bases through multiplication and that their exponents add. And then if we toss on the idea of coefficients, they're going to go ahead and move to the front and all multiply together. Alright, thanks for watching. We'll see you in class.